There is a region of the universe roughly 330 million light-years across that is very nearly empty. Based on the average density of matter, it should contain something like 2,000 galaxies. Surveys have found on the order of 60. It is not a hole in the sense of nothing existing there. It is a hole in the sense that almost everything that should be there is missing. It is called the Boötes void, after the constellation you would look towards to find it, and its center lies roughly 700 million light-years from us. It was identified in 1981 by a team including Robert Kirshner, working from a survey of galaxy redshifts. They were not looking for a void. They were mapping how galaxies are distributed, and the map came back with a gap in it that was far too large to ignore. The number that makes it land is not the diameter. It is the crossing time. Light needs about 330 million years to travel from one side of this emptiness to the other. When light entered it on one side, there were no dinosaurs on Earth yet. By the time it came out the other side, they had appeared, dominated the planet for 150 million years, and been extinct for tens of millions. The reason astronomers keep returning to it is not that it breaks physics. It does not. It is that it forces a question about observation itself. Everything we know about the universe being enormous, expanding, and full of galaxies, we learned by looking outward from an ordinary place. Standing somewhere else, the same telescopes would have told us something very different. Before the 1970s, the working assumption was that on large scales galaxies were scattered roughly evenly through space. That assumption came apart when astronomers started measuring distances in bulk. A galaxy's redshift gives you how fast it is receding, and its recession speed gives you a distance. Do that for thousands of galaxies and a flat picture of the sky becomes a three-dimensional map. The maps did not show an even scatter. They showed structure. Galaxies are strung along filaments, gathered into clusters where filaments intersect, spread into sheets, and between those features are enormous rounded regions with almost nothing in them. The standard description is a cosmic web, and the honest visual comparison is soap foam. The galaxies live on the bubble walls. The interiors are the voids. This structure is not a coincidence, and it is not decoration. It is the amplified fossil of tiny density variations in the very early universe, regions that started out a fraction of a % denser or thinner than average. Gravity does the rest over billions of years in the most unfair way possible. Slightly dense regions pull in more matter and become denser, and slightly thin regions lose what little they had. So voids are not anomalies in the cosmic web. They are the majority of it by volume. Most of the universe is void. What made Boötes worth naming was scale. Ordinary voids run to a few tens of millions of light-years. This one is an order of magnitude larger, which is genuinely difficult to produce from the standard growth of small initial fluctuations in the available time. The void is not perfectly empty, and the objects inside it are the most informative thing about it. Follow-up surveys through the 1980s found galaxies within the region, and by the late 1980s the count had reached roughly 60. That is still catastrophically fewer than the region should hold, but it is not zero, and their arrangement is not random. Rather than being scattered through the volume, many of the galaxies that are there appear to lie along a tube-like structure crossing part of the void. That is a strong hint about origin. It looks less like one gigantic bubble that formed empty and more like the remains of internal walls, the seams left behind where smaller voids merged into a single larger one. That merger idea is the leading explanation, and it resolves most of the difficulty. Producing one 300 million light-year void directly from the initial density fluctuations is hard. Producing a set of ordinary voids that expand, press against each other, drain the walls between them and coalesce is straightforward, because that is what voids do. They expand faster than the universe as a whole. The galaxies that survive inside voids are also physically different in a way that supports the picture. Void galaxies tend to be smaller, bluer, and still actively forming stars, while galaxies in dense clusters are more often large, red, and finished. Isolation preserves gas. A galaxy with no neighbors to strip it or merge with it keeps its fuel, and keeps making stars long after its crowded relatives have stopped. The astronomer Greg Aldering framed the consequence in a way that has been quoted ever since. If the Milky Way had been at the center of the Boötes void, we would not have known there were other galaxies until the 1960s. It sounds like a rhetorical flourish. It is an arithmetic claim about telescope sensitivity and distance, and it holds up. The reason is that brightness falls off with the square of distance. Our nearest large neighbor, Andromeda, sits about 2.5 million light-years away and is faintly visible to the unaided eye under dark skies. From the center of a void of this size, the nearest galaxies would be more than 100 million light-years off. The same objects would be tens of thousands of times fainter. So the history of astronomy would have unfolded differently. Edwin Hubble established in the 1920s that the fuzzy patches called nebulae were separate galaxies at enormous distances, and that finding is what turned the universe from one system into billions. Inside the void, those patches would be beyond the reach of the instruments of that era. The sky would look like stars and blackness. And a reasonable astronomer in that situation would build a reasonable and completely wrong cosmology. One galaxy surrounded by void, static as far as anyone could measure. No expansion, because expansion was discovered by watching other galaxies recede. No Big Bang, because the Big Bang was inferred from that recession. Every observation correct, every conclusion mistaken, because of where the observatory happened to sit. Modern cosmology has stopped treating voids as gaps in the data and started using them as equipment. A void is a region where gravity from ordinary matter is weak, which makes it the cleanest available place to watch the effect of whatever is accelerating the expansion of the universe. In a dense cluster, gravity dominates. In a void, it does not. Voids also expand faster than the universe average, because matter is draining out of them into the surrounding walls. That makes their growth rate a measurable prediction. Compare the observed sizes and shapes of many voids against what different models of dark energy predict, and the voids become a test rather than a curiosity. There is a subtler use involving light passing through. A photon crossing a void falls into a shallow gravitational well on entry and has to climb out the other side. If the universe were not accelerating, the climb would exactly cancel the fall. Because the expansion is accelerating, the well flattens slightly while the photon is inside, so it loses a little less energy than it gained. That tiny imbalance is detectable statistically across many voids, which is a strange reversal of how this started. Boötes was first reported as a problem, a hole where the data should have been, large enough that some astronomers suspected a survey artifact. It is now a measuring device. The emptiest place we know of is one of the better instruments we have for studying the thing filling everything else. It is worth resisting one framing that gets attached to this object. The Boötes void is not lonely, terrifying, or hostile. It is not a place where something went wrong. Voids are the ordinary majority state of the universe by volume, and the crowded filaments where galaxies like ours live are the unusual, thin exception. There is also a quiet correction hiding in the 60 galaxies. Something does live there. Those galaxies formed, held on to their gas, and are still producing new stars now, in the emptiest large region anyone has mapped. Isolation did not sterilize them. In several measurable respects, it left them younger than their crowded counterparts. The genuinely unsettling part is not the emptiness. It is the epistemology. We built our entire account of the universe from one vantage point, and we know from this object that the vantage point determines what is visible. An observer inside the void, with our exact instruments and our exact intelligence, would have written a confident and wrong textbook. Which leaves an uncomfortable question pointed back at us. We are not in a void. We are in a reasonably populated part of the cosmic web, which is why we could see far enough to work out expansion and the Big Bang. But nobody has shown that our position is good enough to reveal everything, only that it was good enough to reveal more than the void would have. Somewhere there may be a better vantage point, and from it, our current cosmology is the confident and wrong textbook.